flow, making scheduling problems. So this is part of network, and we're going to be talking about flow problems. So when we've got a weighted graph, and there's numbers on all the edges, they're called weights. Now, again, it could be distance, time, cost, could be anything, could be even water flow. Where it's a directed graph, that means there's a direction involved in it, and of course we have to be able to follow that flow, that direction. A short name for it is called a diagraph. Okay, minimum flow. Well, let's talk about flow. So, we've got to have things going from one point to the other. So it's got to flow from one section to the other. So if we've got a big pipe here, 25 litres per minute, and we've got another going into another big pipe, then really we can't have 58 litres per minute flowing through. It's only going to be 25, even though we've got a maximum here. With this one here, in this second example, we've got 58 litres per minute in there, but this small pipe on the end is only going to allow 25 litres per minute. So again, we can only pass 25 litres per minute. So when we're looking at maximum flow, we're looking at the smallest capacity, the smallest cut. So that's something I want you to keep in mind. Maximum flow is minimum cut, minimum capacity. Example 1 says in the diagram shown below, the vertices A, B, C, D and E represent towns. The edges of the graph represent roads, and the weights of these edges are the maximum number of cars that can travel on the road each hour. The roads allow only one-way travel. We can see that because there is an arrow on the roads. There is a direction. Part A, find the maximum flow from A to E. Okay, so I think about it like this. I can get 300 cars from here to here. So there's 300. Out of those 300, I can take 600 along this road. Okay, so that means I can get 300 to here. Out of the 300 that are here now, I can take up to 800 along this road. So I've got 300 sitting at the moment, not an issue. Along this road, A to D, I can bring 500 cars. So I've got 500 sitting at D at the moment. But when I get to D, I can only bring 150 along the road from D to E. So I've got 150 there. So altogether, it says through town C. So let me rephrase that. So really through town C, there's only 300. Can't have this part down here. Part B, from the maximum traffic flow from A to E overall. That's the part that I was doing. That includes the 150 here, so that's 450 overall. That's how we get this 450 cars over here. Part C, a new road is being built to allow for traffic from town D to town C. Road can carry 500 passengers, 500 cars per hour. Add this road to the network. Okay, it's already added there. There it is. Find the maximum traffic flow from A to E overall after this road is built. So again, I can bring 300 here. Out of the 300, I can bring all of them because I can get 600 to there. Over here, there was 500. It's not shown on this. I can bring 500 to the D. On this road, there was 150. It wasn't shown. Now, out of these 500, I can split this up. I can take 150 this way, so I get 150 reaching there already. So now I've got 350 left. So if I take away 150, I've got 350. All 350 can come along this road. So when I add them to this, I've got 650 there at the moment. Can I take all those 650 along the road from C to E? Yes, I can, because I can take 800 along that road. So I can bring all 650 there. So that means altogether, when I add them up, I get 800 cars all together flowing from A to E. Now, we can't keep doing that all the time. Okay, so there's a way that we can work this out. Remember what we said worked out before, that the maximum flow, the maximum I can take from the start to the end is the minimum cut. So we can divide it. How do we even try and think about the minimum cut? We try and stop people, cars, whatever it is, going from one point to the other point. That means we can't just cut down here. We have to cut the whole thing. Okay, be aware that you never cut across like this. Okay, because that's not going to help you, because people can go from S to B to A, or even from S to C to A. So think about trying to stop water. Think about trying to blow up roads to stop people using those roads. Very important. Direction is important here. We do not need to worry about cutting or counting it if we're going in the wrong direction. Okay? If we're going backwards, because remember, water can't flow uphill, so there's no point cutting that pipe. It's not going to get there. So as I said, we're going to do the cut capacity, the maximum flow by working out this minimum cut. That's what we're going to do with it. Okay. So let's do example 1. Example 1 says, calculate the capacity of the 4 cuts shown in the network below. The source is vertex S and the sink is vertex T. It doesn't matter, we've got to start at S and finish at T. Well, yes, we need to do both of these roads to stop it. So we've got to add them up. So we've got 15 plus 20. So C1 is 15 plus 20, 35. C2. Yes, we need to cut there and we need to cut there, but we don't really need the 6 because we can get water going to B, but we can't flow backwards. So we only need the 14 plus the 20, so we've got 34. Do not include that 6. For C3, yes, we need the 14, we need the 15 because it can go from F to C, and we need the 20. So we need 14, 15 and 20. So we got 39, 59. Okay, C4 I'm going to do over here. C4, yes, we need the 10. We need the 20 here, but we don't need the 12 because if I cut here, no water can get to D. So I only need the 10 and the 20, so I've got 30. So what's the capacity? Maximum flow equals the minimum cut. And my minimum cut here equals 30. So I will be going for the 30. Now it doesn't say litres or anything, so I'm not going to say anything. But 30 would be my one for that one. Always the minimum one. Now this one was cut for us. Don't expect it to be cut for you. So example 2, I'll change it to a black. Okay, example 2 says determine the maximum flow from S to T for the diagraph shown below. So I'll always cut here. There's 1. 11 plus 8, 19. Okay, I'm going to cut here. 5 plus 3 plus 1, 9. Okay, let me see where else I can cut. Yes, I can cut like this, but I'm going to have bigger than 9 because that's already 11. So forget that one. I can cut like this. Okay, I'll need the 8, I'll need the 3, and I'll need the 1 that's already bigger than 9. So forget that one. I'm not even going to add it. Okay. Do we have one smaller? We've got to sort of work out where we can do one smaller. So let me just change colour. What about if I go like this? 3, 5, 3 and 1. I won't need the 5, I'll need the 3. I'll need that 3 and that 1. So I've got 3 plus 3 plus 1. I've got 7. So 7 is it. Of course, I would be naming them as cut 1, cut 2, cut 3, cut 4, cut 5, and working out the total for each one. But maximum flow equal the minimum cut, which I found as 7, which equals 7. Okay. Now you need, in the SAC you'll need to add up to show the totals, but in an exam you won't need to. Example 3 says stormwater enters a network of pipes at either Dunlop North, which is source 1, which is right there, or Dunlop South, which is source 2, and flows into the ocean at outlet 1 or outlet 2. On the network diagram below, the pipes are represented by straight lines with arrows that indicate the direction of flow of water. Water cannot flow through a pipe in the opposite direction. The numbers next to the arrows represent the maximum rate in kilolitres per minute at which storm water can flow through each pipe. Determine the maximum rate in kilolitres per minute at which water can flow from these pipes into the ocean at outlet 1 and outlet 2. Now, the answers are down the bottom. This is a VCAA 2011 exam, but I'm going to do it for you. Okay, so we've got water coming in here. Okay, so I can cut this way. That's 1200. I can cut this way, which is 700. I'm going to sort of look for anything that's more quicker. So if I cut this way, because that's smaller numbers, but I'll need to include the 3, and the 100, or else I'll have water flowing there. So that gives me 700 anyway. So in outlet 1, maximum flow equals 700, and it is kilolitres per minute. Okay, for this one here, again, remember water is coming in, so you have to be careful. You'd have to cut that part as well. So I've got 3, 4, 5, 700 there. Okay, if I do this, 6 and 3, that's 900. Okay, where else is there something smaller? Well, I can do the 2, the 3, the 3, the 6. That's giving me 3, 6, 7, 8. That's 900. I can't see anywhere smaller, but let me do this one. So I've got to count this one, count this one, count this one, count this one. So I've got 4, 6, 7. That's 1,000 there. So again, this one here will be 700. So maximum flow here equals 700 kilolitres per minute. And that's what I've worked out down here anyway. Okay, I mean, I've shown the cuts there, but you don't need to do all those cuts.